My name is Joseph Wunderlich, a professor of engineering, architecture, and computer science. This is a lecture in architectural materials and methods in a studio class. It's my website. We're in architecture. We're in this course here. And we are now talking about masonry and concrete. Part 1, history. Cut stone, Egyptians, long time ago, 3,000 years or 5,000 years ago. Romans for almost 1,000 years. More than 1,000 years. Bricks, Turkey 7,000 years ago. Bricks of the Egyptians 5,000 years ago. Romans again for over 1,000 years. Bricks. Masonry, stone, and concrete. Long history. Roman Empire. Rome was a kingdom, and then a republic, and then an empire. Roman Empire was quite vast. 53,000 miles of roads. I believe this is the Appian Way. 53,000 miles of roads. Look like this. This is one of a couple different types of designs. You can see they had drainage on the side and would compact a finer grade of sand or soil, and then put pavers and create a drainage ditch. This type. Here's another type. Again, well designed road, well engineered and built, and drainage ditches on either side. The architecti were the chief builders. This is all a military kind of campaign for conquering other people. There were surveyors, levelers, workers carried weapons, rations, utensils, and a saw, hatchet, different tools. The slaves were anybody they captured. Any place they conquered, people became slaves. Prisoners of war, convicted criminals, they performed the hard labor. This is an example, masonry. Bridge, Roman bridge. Let's make this a little smaller here. This is the oldest Roman bridge in Rome. Oh, it's a broken bridge in Rome. Took this picture in 2011. So 53,000 miles of roads. A legion. The Roman legion didn't need a way station, like a toll booth. They charged tolls to other people, and the Romans would set up camps themselves. Example, way station. So the fortifications too, of the walls, certain areas, Hadrian's Wall across Britain, different emperors. Their aqueducts were made of masonry. Roman aqueducts, different types. A inverted siphon. It's a little different than an aqueduct. Aqueduct is gravity fed, but if you want to go across the valley and you just use the principles of fluid mechanics, you can do this kind of thing. Otherwise, you're just going a gentle slope all the way down from the mountains to the city, which is more common actually, that they did. Aqueduct bridges, aqueduct channels, water-powered mills, Roman sewers, still operational to this day. They mix the sewage with the stormwater back then, but today it's just used for stormwater, still functioning. You can see they're using septic as well as runoff here. Long ago. Roman toilets. This is a picture I took of the actual stormwater coming out in 2011 into the Tiber River. Roman Forum. Now, the draining of the swamps here allowed for the unification of the tribes in Rome originally. So environmental engineering had to do with political progress. Greenhouses, stone, greenhouse, cisterns, rainwater collection, Roman Arch, Colosseum. A great feat of engineering for the time. You could actually flood the whole thing and have water battles in here, like this. Pretty complicated engineering for 2,000 years ago. Elevators. Now it's man-powered elevators to raise the terrifying animals out of the floor to play with. Colosseum. New Roman form, Trojans, or Trajan's form. Town center. Shopping mall, still there. It survived a big earthquake because it's built into the hill here. So it looks like I didn't take this picture. Roman baths all over the place. This is actually in England. Heating system, all masonry, built. See the details. Roman concrete, a special kind of concrete, combining lime with volcanic ash to make a mortar and then mixing of fragments of volcanic rock aggregate. Build the Pantheon and Trajan's Market, as well as large piers and breakwaters along the coast. Compare this to modern day Portland cement, which even when reinforced with rebar might last 100 years in a marine environment. And they made things that lasted thousands of years. Pantheon in Rome. There are actually steps buried beneath here, but the buildup of just dust and dirt over time, road level has come up. All unreinforced concrete now. So we're talking about masonry, stone, and concrete, and this is first lecture in the history of that. This is all unreinforced, which for the age of it, over 2,000 years old, and the size of it's pretty amazing. And so they have these coffers, they're called, and they get smaller and thinner and with a lighter weight aggregate as it gets up to the top. And then there's a compression ring at the top here. As it says here, you can see how the forces are distributed here. Forces, lightweight concrete, oculus, lets light in. It's amazing how well lit this is inside. Even I wasn't there on a cloudy day and it still managed to light the place up. And it was raining too, but the rain kind of turns into a mist, and there's floor drains in it also. But it works. Public baths, all masonry. What they used to look like. So, cities, the Roman Empire. Roman Arch again. How that works. And these, it looks like this one's under more stress, but if you look at the range of numbers here, red is on the order of 2,157, probably pounds per square, some kind of stress. And this one's only 1,000. So even though it looks more heated up here, you want to look more at the distribution of load. The arch distributes the load better. Here you have stress concentrations where you could easily have shear right there. Roman brick is thinner. So after the fall of the Roman Empire, 500 AD, Western civilization went into the Dark Ages, medieval times, for 800 years. Feudal times, people lived in castles, mostly masonry. These are Bavaria, Germany. There's one in Belgium I visited. This is Windsor Castle. The actual castle itself originally is over here on the left, fortification, and the rest was built later. Castles. It's our visit to Windsor Castle in 2014. This is Rome, Piazza San Pietro, the St. Peter's Cathedral, or the piazza is out front. This is Florence, Duomo. Quite a feat of engineering to make this dome. I just talked about that in another class today. They use a spiral herringbone brick pattern to make that dome. They actually built the whole building without an idea of how to make the dome, and then later made the dome. So that's the introduction.